Hey Akis, welcome to another video. So today we will be discussing about one of the important topics asked in GATE for the chemistry section, and that is electrochemistry. Before progressing into the video, I would like to remind you that on my channel, I have made a video where I have explained the analysis, that is which chapters are important and what kind of questions will be asked from those particular chapters, and that is for the chemistry section. So do check that out. I'll link it here up in the I button or down in the description below. Please do have a look. Now, without much further ado, let's get right into this video. So for electrochemistry, there are simply some concepts that you need to understand which will help you to solve questions. So firstly, I will explain to you using a numerical. Okay, and then at the end, after I discuss the 3 or 4 numericals, we'll come back to the page and write down all the formulae that are required to solve this. Before going into anything, I just want you to remember this. Oil rich. Okay, so what is oil rich? Oil rich stands for oxidation is loss. What is loss of electron? So oxidation reaction is where electrons are lost. Then what is rich? Rich is reduction, and reduction is actually the gain of electrons. So a reaction where there will be loss of electrons, we'll call it oxidation, and where there will be a gain of electrons, it will be called as reduction. Now, the next kind of thing that you need to remember is where does oxidation takes place or where does reduction takes place? Does it take place at the anode or at the cathode? So to remember this, there is another simple thing that I want you to remember. Anadi means loser, right? So the one that loses electron is definitely the one undergoing oxidation. Okay, so anadi means loser. Okay, anadi is a loser, right? Now, which reaction involves loss of electron? Oxidation. And therefore, by default, at the anode, we have oxidation type of reactions, whereas in the cathode, you will have reduction type of reactions. Just remember these things and your life will be much simpler. Okay. Now let's directly start with this. I have taken up 2-mark questions here. If you understand how to solve questions for 2 marks, then definitely I don't think it is going to be very hard to understand questions worth 1 mark. Now, this is a question asked in GATE 2006. They have given you a cell reaction. Okay, this is a cell representation or a cell notation. This particular cell is generating some kind of EMF which we have to find, right? Now, these cells involve the conversion of chemical energy into electrical energy. And if electrical energy is produced, how much voltage is produced, that will come to know by the EMF of the cell. So the simple formula to calculate EMF of the cell is EMF of the cell is EMF of the cathode minus EMF of the anode. So E0 cell is equal to E0 cathode minus E0 anode. Now, why writing E0 is important and how is it different from E cell? So you will find E0 cell and you will also find E cell. Now, when is E0 cell used? E0 cell is used when the reaction is carried out at standard condition. In standard condition, one of the important thing is that the concentration of the chemical should be 1 molar, the solution. Whereas when we say E cell, it is where the concentration is not 1 molar. So now in this case, they have asked you the standard EMF, so you don't have to worry about anything major. So whenever there is standard EMF, this is a simple formula you have to follow. For E cell, the formula is different. So for E0 cell, it is E0 cathode minus E0 anode. Now you have to figure out what is the cathode, what is the anode. So this is the cell reaction. Now one thing you need to remember is this double dundee. This double dundee is nothing but the salt bridge. Okay. Now, in always to the left side of the salt bridge, you will have the anode always. And to the right hand side of the salt bridge, you will have a cathode. This is the convention. Okay, so this double Dundee salt bridge, it basically connects the two half cells. To the left, you have anode. To the right, you will have cathode. Now, you have to remember what happens at the anode. Is it oxidation or is it reduction? So for that, I gave you a mnemonic. Anode is anadi. Anadi meaning loss of electrons. Loss of electrons will happen at the loss of electron happen during oxidation. So whichever species amongst this is undergoing oxidation, that is the anode, the other one is the cathode. Now here you don't have to use much brain, you just have to see what is at the left side. The species at the left is the one that is undergoing oxidation, and therefore that's our anode. So this we know right here is the anode. Then what is the cathode? The Cu is the cathode, so this is cathode. Now simply what you need to do is substitute in this equation. So E0 cell will be equal to E0 of cathode, that is minus 0.337, minus of minus, that is will become plus 0.763. So calculate this, and whatever answer you get, that will be the standard EMF. Is this clear? Any questions? No. So if you calculate it, it comes out to be 1.1 volt. Okay, it's positive obviously because this is a bigger number. So that is the EMF of the cell. Very, very simple. You don't have to know much chemistry to understand. All you need to remember is in the cell notation, the one to the left is the anode, the one to the right is the cathode, and you will use this formula E0 cell equal to E0 cathode minus E0 anode. But mind you, you have to see whether it is E0 or it is only E cell. If it is standard EMF for E0, use this formula. Now, there is another part to this question. They are saying the value of log K for this reaction will be what? Now, what is K? They have also told you that it is the equilibrium constant. So, whatever you require to understand, they have given you over here. Now, obviously, to understand the value of K, you need to know the formula. Now, this formula is actually a part of two different formulas. So, I'll tell you both the formulas. Further on also, it will be useful. Okay, so there is one formula to calculate the delta G. Delta G is the Gibbs free energy. So, to understand whether some chemical, okay, will interact spontaneously to form electricity or no, we need to know the delta G. I'm sure you all know in thermodynamics also, if delta G is negative, that reaction will be spontaneous. That is, it will occur on its own. Whereas if it is positive, then it will be non-spontaneous. So similarly, when the reaction is spontaneous, then that's when EMF will be generated. Otherwise, you have to give electricity to make it occur. Okay, so don't worry much about that. Just remember that delta G naught is Gibbs free energy, and the formula is delta G naught equal to minus NF E0 cell. Okay, so if they ever ask you to find out the reaction is spontaneous or not, or whether Gibbs free energy's value, you can use this formula. However, here they have obviously not asked us Gibbs free energy. So then what is it that connects K with EMF? We have to see. So there is another formula, that is delta G naught is equal to minus RT ln K. Okay, this is the formula. Delta G naught equal to minus RT ln K. And here's where your K comes, right? Now, since left hand side is same, we can equate the two and get our new formula, that is this. So this will get cancelled. Also, you know, if you want to convert this into log to the base 10, you have to multiply by 2.303, right? So keeping this to one end, just let's keep this to one end, ln K for now, it will become minus NF E0 cell divided by RT, right? Now, if I want to convert this to log to the base 10K, then log to the base 10K will be equal to, you will have to multiply by 2.303. So this will go and divide down, right? So it will become NF E0 cell divided by 2.303 R into T. Now, if you carefully observe, you have all the values, right? So to find log to the base 10k, you have n. Now, what is n here? N is equal to the number of electrons involved. So as you can see, Zn is becoming Zn2 plus, and Cu2 plus accepts that electron to become Cu. So how many electrons will be involved, you can make out from the charge. So 2 electrons are involved, therefore n's value is 2. So here you will put 2. F value they have already given you, 96500. E0 cell is already found by you in the previous problem. So 1.1 divided by 2.303. R is given in the question in the given section right here, and T. Now for T, they have given you in the question again. So that is 298 Kelvin. Now mind you, the temperature should be in Kelvin. Sometimes they give you in degrees Celsius. So you have to calculate that out. When you calculate this, you will ultimately get the answer as option B. Do solve it out. You can pause the video and do the same. Okay, so as simple as this, with these 3 formulae, you can solve any question that comes. Okay, now let's move on to another type of question. Now they are asking you calculate the EMF of the cell. See the language. The EMF of the cell, which is at 298.15 Kelvin, and the notation is this: standard reaction potential. So they have given you the standard reaction potential. Means what they have given you? E0 cell is given, right? So they have given you the E0 cell for this particular part, actually for this reaction. So instead of writing in the cell, I will mention it as Ag plus Ag, that is given as minus 0.8 volt. And they have asked you to calculate the EMF of this cell. Now, your standard EMF is not asked, E cell is asked. So the previous formula won't work. And you can also understand, see, this is what I was talking about. This is a non-standard condition because the concentration here is not 1 molar, right? Therefore, for such kind of conditions, you require the Nernst equation to calculate the EMF of the cell. So what is Nernst equation? E cell. E cell is equal to E0 cell minus 0.0592 upon N log to the base 10 product upon reactant. Okay, so this is a formula that you will have to apply in order to get the answer for this particular reaction. Now you need to again know what each term is. Correct. So E0 cell. Now E0 cell is actually found how? It is E0 of the cathode minus E0 of anode. But this is slightly a trick question. Why? Look at the left, it's Ag, Ag plus. Look at the right, it's Ag plus Ag. Isn't it the same chemical at both ends? If it is the same chemical at both ends, do you think anybody will accept electron and the other one will donate? No, they are both the same species. Here we could remove the E0 cell because one was losing, that Zn was losing its electrons. Cu2 plus was accepting the electrons. But in this case, nothing like that. And therefore, the E0 of this cell will be a big 0. So in here at E0, you'll write 0 minus 0.0592 upon N. Now, what will be the value for N? N is the number of electrons involved in the reaction. Very simple. Ag becomes Ag plus. So how will Ag become Ag plus? Plus means it has 1 electron less, no? That means this must have lost 1 electron. So how many electrons are involved in this reaction? Only 1. So you will write 1. Log of product upon reactant, right? So what is your product? Look here carefully. What is your product? It's Ag plus. What is the concentration of Ag plus? It's 0.01 molar. What is your reactant? Your reactant is Ag. What is the concentration of Ag? Since Ag is a solid, its its concentration will be taken as unity 1. So over here 1. So now the minus sign 0.0592, and this is log 10 to the power minus 2, right? So minus 2 will come over here, it will become plus. So this is plus 0.0592 into 2 into log 10. Now log 10 to the base 10 is 1. So you just multiply this, and this is the answer, right? So what is the most closest to this? 0.1. So option A is the closest, and therefore option A will be our answer. Understanding? Hopefully this is clear. We'll do one last question and then we'll wind up. So the question says the standard potential. Okay, the standard potential is for these two halves. So one of it obviously will be the oxidation half and the other one will be the reduction half. So they have given you these values and they're asking you to calculate the standard free energy change, that is delta G naught. Now I've given you the formula, delta G naught is equal to minus NF E0 cell. Now you'll say, why didn't you take the other formula? Because here K is not given. Therefore, this formula. Now, what all we need? So now you need to find the number of electrons involved in the reaction, right? That is necessary. F is the Faraday's constant, whose value they have already given to you, that is 96500 coulomb per mole. And E0, I told you, it's E0 cathode minus E0 anode. E0 cathode minus E0 anode is the EMF of the cell, standard EMF. Now, in the previous problems, they used to give you a cell notation. And I told you that whatever is to the left of the salt bridge, you take it as anode. Whatever is to the right, you take it as a cathode. Now, here we have a slight problem. What the problem is? That you don't know what is your cathode and what is your anode. So, how to solve such kind of questions? Very simple, I'll tell you. So, look at the species to the left and the right. So can you see here Cu has become Cu2 plus. Can you tell me how Cu can become Cu2 plus? It's become positive. Means what? It has lost electrons. So this Cu must have definitely lost electron. But how many electrons? If it loses one electron, it would be Cu plus. But it's 2 plus over here, means it has lost 2 electrons. Understanding? Now, next, what happens to these 2 electrons? They will be accepted by someone, and therefore you can see that there are 2 Ag molecules here. So one Ag will accept 1 electron to form a Ag atom. So 1 Ag plus accepts 1 electron to find 1 Ag, but we have 2 electrons, so therefore 2 Ag plus will accept 2 electrons to form 2 Ag. Now this is oxidation or reduction. Remember, oil-rich oxidation is loss. So as we can see, there is loss in the first. So this is oxidation. And oxidation kahan hota hai? Anode is anadi. Anadi matlab it loses. So this must be our anode. And then by default, this one is the cathode because here there's reduction. Now can you find E0 cell? Who is our cathode? Ag. So where's the value for Ag? Right here. So you have 0.8 minus. What is our anode? Cu. So you have 0.34. Solve it. How much would you get? So this will be 7. This is 6. And this is 4. Right? So 0.46. So now we got this particular answer. Now, after this, what is the next step? Next, what we need to do? We have to find N. Now, what is N? Can you see how many electrons are involved here? 2 electrons. So, what is the value of N? N equal to 2. Now, we have everything we require. Delta G naught is equal to minus N, that is 2, into F given 96500 into E0 cell, that is 0.46. Multiply everything and you will get an answer like this, minus 88780. However, they have asked you to give them answer in what? Kilojoules or joules, you have to see. Okay. So they have asked you to give answer in kilojoule per mole. But what you get over here is in joules. So you have to convert joule to kilojoule. So how are you going to do that? Shift the decimal. So 1, 2, 3 places. So that will be minus 88.7 kilojoules per mole. This is the answer. So this is how you can solve questions. There is another question, I suppose. So I will definitely put up some more questions in my Telegram group for you to practice. So hopefully you look at it. Finally, the summary of all the formula. So jot down all these formula and do revise it before you go to the examination hall. First trick you remember, oil ridge. Oxidation is loss, reduction is gain. Second trick you remember, anode is anardi. That is, there's going to be loss of electron and that happens during an oxidation reaction. And coming to the EMF of the cell, standard EMF of the cell is equal to EMF of the cathode minus EMF at the anode, right? Then the fourth formula, if you have to find only EMF of the cell, then you are going to use this formula where N over here is the number of electrons involved in the reaction and log of concentration of product upon concentration of reactant. This is the Nernst equation. Then next you should know another formula for delta G naught, that is minus NFE0 cell. And if equilibrium constant needs to be calculated, then the formula will be minus RT ln K, or you can also write it as 2.303 RT log to the base 10 K. So that's it for me for the summary for electrochemistry part. This will definitely help you to calculate most of the questions that can be asked from this section. If you want me to do any other videos like this, do let me know. I'm always eager to hear what you want me to shoot. So without much further ado, I'll wish you goodbye for this video and keep studying. Bye.